Hello and welcome back. We're now going to look at the first of the tests in the testing sequence. Regulation 612.2.1 requires that a continuity test shall be made. And there are two methods which have evolved to measure the continuity of protective conductors. These are known as test method 1 and test method 2. Both methods are applicable to radial circuits only and should not be applied to ring final circuits, which have their own specific continuity test method. The inspector may opt to use either method, but many find it preferable to use test method 1 when testing final circuits, because it will help reduce hazards associated with live testing during subsequent earth fault loop impedance tests. However, it does remain necessary to use test method 2 to verify the continuity of main protective conductors, such as the earthing conductor and main protective bonding conductors. So let's start with test method 1. This measures the resistance of the line conductor, which we refer to as R1, and the resistance of the protective conductor, which we refer to as R2. The measurement attained is therefore the combined R1 plus R2 of the circuit in ohms. The test is carried out using a low resistance ohm meter or multifunction test instrument switched to the continuity setting. The test equipment should be able to perform a test at a no load voltage between 4 to 24 volts with a short circuit current of not less than 200 milliamps. To carry out the test, disconnect both the line conductor and the circuit protective conductor at the distribution board or consumer unit, and temporarily connect them together using a terminal strip connector block. The test is then carried out at the furthest part of the circuit, which we identified during the inspection process. Alternatively, depending on the inspector's preference, the connection could be made at the furthest part of the circuit and the test carried out at the distribution board or consumer unit. The test probes are connected between the line conductor and circuit protective conductor, and a measurement of resistance is taken. This will be displayed in ohms on the test equipment, and the value obtained will depend on the length and the cross-sectional area of the conductors of the cable and the tightness of the cable terminations. If there is a break in either the line or circuit protective conductor, i.e. an open circuit, the value displayed will be a high value, greater than 2000 ohms. So check to see if there is a switch in the circuit that may require to be closed, and remember to test all line conductors, including strappers or pass wires, which may have been installed to facilitate two-way switching of lighting. Also, it's important to note that the resistance value obtained includes the resistance of the test instrument test leads. So this will need to be known and deducted from the measured value before recording the test results. The resistance of the test leads can either be measured separately and deducted, or alternatively, the continuity null feature of the test instrument can be used to achieve this. The compensated measured value can then be recorded on the schedule of test results in the relevant R1 plus R2 column provided for the continuity test results. Now, as mentioned previously, test method 1 may help reduce the hazards associated with live testing if it is used as part of an alternative method to verify the earth fault loop impedance of final circuits. Now, as per regulation 621.9 of BS 7671, the earth fault loop impedance, ZS, can be determined by adding the measured R1 plus R2 obtained in test method 1 to the measured earth fault loop impedance external to the installation, ZE, using the formula ZS equals ZE plus R1 plus R2. This is covered in video 7, where we demonstrate earth fault loop impedance testing, which is the first of the live tests. After completion of test method 1, remember to reinstate the circuit back to its original completed condition, and be sure you do so on completion of all tests carried out. So now let's have a look at test method 2. This measures the resistance of the circuit protective conductor, R2, only, and as per test method 1, it is carried out using a continuity test instrument or multifunction test instrument set to the continuity setting. To carry out this test, you will need a wandering lead, which is a length of single core cable long enough to reach the furthest point of the installation. One end of the wandering lead is connected to the main earthing terminal, with the other end connected to a test instrument lead. The other test instrument lead is then used to connect via a suitable test probe to the protective conductor being tested. This provides an easy method to verify the continuity of the main protective conductors of the installation, including the earthing conductor and main and supplementary equipotential bonding conductors. Main protective bonding conductors will be connected to the extraneous conductive parts of the installation, such as gas or water pipes, and should be accessible for inspection and test. Similar to test method 1, the inspector should remember to compensate measured resistance values to take account of the resistance of the test instrument leads, which in this instance will also have to include the resistance of the wandering lead. The compensated value can then be recorded in the continuity column of the schedule of test results, R2 column, if test method 2 has been used to verify the continuity of circuit protective conductors of circuits. The inspector should also note that when verifying the main protective conductors of the installation, that the test results obtained will be low values in the order of 0.05 ohms, but not recorded on the schedule of test results. The continuity of the main protective conductors should, however, be indicated as satisfactory by inserting a tick in the relevant boxes provided for this purpose on page 2 of the electrical installation certificate that will be accompanied by the schedule of test results. So thanks for watching, and now watch the next video in the series titled Continuity of Ring Final Circuits.